Cadet Luker briefing a good example of a quality rep. For this quality rep, I will be using question 6.4.3 out of the textbook. The first step of the quality rep is the problem statement. The problem statement is where you outline what the question is asking you to find. For this particular problem, I will be calculating the work required to lift a rope that has a density of 0.5 pounds per foot, is 50 feet long, and is dangling from the side of a 120-foot building. In part A, I will be calculating that from when it's fully extended, all the way from the bottom up to the top of the building. And for part B, I will be calculating when it's at half length, so whenever it's 25 feet long to the top of the building. The second step of the quality rep are assumptions. It is important for the assumptions that you outline why it is necessary and why it is reasonable to make it a good assumption. For this particular problem, my assumption is that the rope raises completely vertical. This is necessary because the angle of the rope will affect the work required by changing the force inflicted by the rope on a pulling mechanism. This assumption is reasonable because the building could block the wind or any other outside force that would affect the angle of the rope. In the formulation step, you should be listing any parameters that are given, any variables you're trying to find, equations that you're going to be using, and any diagram to help illustrate the problem. For this one, I outlined the force equation, which is mass times acceleration. We're working in pounds and feet for this problem, so pounds takes into account mass and acceleration. That's our force, 0.5 pounds per feet. The equation for work, which is force times distance, distance being the interval that we will be using. I also outlined the integral to find work, which is on the interval of a to b, f of x dx. Over here, I made an illustration to help visualize the problem. I have our 120-foot tall building, beautifully drawn windows, and our 50-foot rope attached to a pulling mechanism attached to the building. After the formulation step, we'll move on to the methodology step. And in the methodology step, this is where, in paragraph form, you will outline how you are going to solve the problem. Within the methodology, you should be listing strategies listed in the textbook and give proper reference to those strategies. For this one, I will be using the work integral, which I listed in my formulation, my reverse power rule, which is located on reference page 6, and the definition of a definite integral on page 378. The final step of the quality rep is the results. For part A, I worked it all out, starting with my integral f of x turned into 0.5x, my interval being 0 to 50. Go through the derivative, find the antiderivative of it. Then use the definition of a definite integral, and I get 625 foot-pounds. Double underline, A and S for answer. Those are labeled. For part B, I am finding on the interval 25 to 50 because I'm doing that top half. Again, same f of x and dx. Reverse power rule, find my antiderivative. Definition of definite integral. And I wind up with 468.75 foot-pounds. Double underline, answer, clearly labeled. Those are all parts of the results. It is important to make sure that whoever is grading your quality rep can clearly find those. The quality rep is good for helping to work out those difficult problems. It's good for organizing all your information. That way when someone looks at your problem, if you somehow go awry, people can look at your information and see that it follows, even if you've fat-fingered your calculator. This has been Cadet Luker briefing quality rep.